All right, so next up, we're going to look at hybridization. And so hybridization is a part of valence bond theory. And the addition of hybridization to the valence bond theory gets you to approximately the same results as Lewis and Vesper. And so you might be thinking, well, if it gets me the same results, why even learn about it? It's because it explains some additional properties. And more importantly, it starts to build the principles of what's known as molecular orbital theory, which we'll study a little bit later on. And so what is this hybridization? Let's check it out. So hybridization, when we say hybridization, what we mean is that the orbitals on a molecule are not necessarily the same as those found on a lone atom. And so what happens is these atomic orbitals mix and thus hybridize to form new hybrid orbitals. However, the number of total orbitals is preserved. So if you had 3 atomic orbitals, you're going to have 3 hybrid orbitals, 4 atomic orbitals, 4 hybrid orbitals. So one thing you need to know with hybridization is be able to identify the hybridization on an atom. What is the hybridization of its orbitals? And it's actually really easy. So to find hybridization, all we do is count the number of things attached. And so these things, just like previously, they can be other atoms or lone pairs. And so however many things we have, that's how many orbitals we're going to hybridize. And so if we think about what orbitals we have to mix and match, we have an s orbital and we only have one of them per n, right? Next up is p. You think there's 3 p orbitals, so there's 3 of these. And then d, there's 5 of them. And we won't go into f orbitals. So all you have to do is count the number of things and then say that hybridization. Mix as many orbitals as you need to get to your number of things. And you want to go from low energy to high energy. So the first thing you're going to do is add an s orbital. Then after that, after you run out of s orbitals, add some p orbitals. After you run out of p orbitals, add some d orbitals. So if we're thinking about 2 things, we're thinking about 2 orbitals. We're going to start with 1 s and then 1 p. So just sp hybridized. If we have 3 things, that's 3 orbitals, so an sp2 hybridization. If you have 4 things, that's 4 orbitals, so it's sp3 hybridization. If you have 5 things, you can do sp3. That's 4 things, and now you've used up all your p orbitals. Now you need to start using d orbitals, so it's sp3d. That's 5 orbitals, 5 things. 6 things is 6 orbitals, so that'll be sp3d2. So overall, pretty simple. Let's take a look at what these hybridized orbitals look like next.